So good evening everybody. Those who have joined online, please make sure that your video is on. And I can see many students have joined online today. Why? Because of long weekend, people have traveled to your natives or what?
I'm traveling, sir.
Oh, you are traveling, Shrish?
Yes, sir.
Okay, then you can have your video off, but be attentive in the class, okay?
Yes, sir.
Fine.
Okay, I'm first patient, sir. I'm online.
Fine, Gaina, no problem. What about Lakshita, Indumati, Soumya, Karthikeyan? Why is your video still off? Fast. We are getting late for the class. Yes. Karthikeyan, if you are able to hear me, your video should be on. So, Pagalavan, I think this is the first class for you, if I am right, isn't it? First physics class at least.
Yes, sir.
Which school you belong to?
MEV.
Maharishi Vidya Mandir.
Yes, sir.
You thought for 2 seconds and told the answer yes. Okay. So, what is happening at your school now? Which chapter is going on?
We normally starting first chapter, sir.
Which school you are? Maharishi Vidya Mandir, if I am right. Which Maharishi Vidya Mandir? Mambakam. Is it Mambakam?
It says with is very low. Can I join from YouTube live?
Your
No,
wish.
sir.
Then which Maharishi Pagalavan?
I don't know the full form of the school, sir.
That is great. When you joined the school, man?
This year, sir.
This year means how many months before?
4 months, sir.
So 4 months you are studying in a place which you don't even know the name of the place. That is great of you, man. And in 4 months you are now only studying first chapter of physics
Sports day was happening, sir.
for 4 months.
Yes, sir.
I don't know, man, whether I am sleeping or you are something is happening. If I am in dreams, then you are awake, or if I am awake, then you are in dream. Something is wrong. 4 months school is running and 4 months they are preparing for only sports day. No class happened of physics till now.
Some classes happen, sir. First lesson only.
I understand that. Okay, where you stay? Which place you stay?
Yes, sir.
SSM Nagar you stay. Which school you go? MVV.
MEV, sir.
MAV. MAV CBSE school.
Yes, sir.
Anybody has any idea? Okay, fine. Anyhow, whatever it may be, let us not go into that. Already I am live and people will be scolding me, those who are seeing what he is doing. So, fine, Pagalavan, no problem. We are learning a chapter called as work, energy and power from the previous class. Lakshita, why have you off your video? Soumya, why is your video off? Please make sure the video is on always. Coming back. So, I don't know how much you will understand today, Pagalavan, because we are in middle of a chapter. I'll try to keep it as simple as possible, but you will wait after the class gets over and I will tell you how to cope up with the portions that you have missed. Okay?
Okay.
Okay. So, I hope you have realized by now that you are in 11th standard. You know that? You are in 11th standard now?
Yes, sir.
And 11th standard is not like 9th and 10th. Have you realized it by now?
Yes, sir.
So, it is way tougher than a 9th and 10th. I hope you have experienced it by now.
Yes, sir.
So, the strategies of preparation also should not be same as 9th and 10th. If you are still going to be in the mind or set of how you studied for 9th and 10th, you are going to study for 11th and 12th, it will not work out. You have to give your best, you have to study very hard if you want to do something good in 11th and 12th. Okay?
Okay, sir.
Fine. So, let us start today's class, and in today's class we are going to continue from where we left. And if I tell you where we left last time, in the last topic that we took was, what was the last topic which we have taken? Work, energy and power. From there we learned work energy theorem. So some people like Kirtish Kumar or Nitishwar, if your bandwidth is little low or something problem is there in your device, you can even log in from YouTube live if you want, if you have any problem in this.
Sir.
Yes.
Hello, sir.
Yeah, Kirtish.
சார் நான் வந்து வீடியோ இல்லாட்டி வாய்ஸ் ஆன் பண்ணா உங்க வாய்ஸ் தான் பிரேக் ஆகுது, வீடியோ ஸ்டக் ஆகுது சார்.
அதான் சொன்னேன், you can go to YouTube live, man. I'll share the link in the group, okay?
ஓகே சார்.
Yes. So if somebody has network problem, you always have an option of watching the whole class in the YouTube. That's why we are streaming it for you to have an easy access. I am posting it in the group, man. You can see from there and you can join.
ஓகே சார்.
Okay. Why? Portion? First 6 chapters. We are in which chapter, you know? 5th chapter. Then why are you doubting me, man? You'll finish, don't worry. Okay. So let us go into the class. I have shared the link for the YouTube live. If somebody has problem in their internet, they can always join there and you can ask your doubts in the chat section. I am always having an eye on that and I am replying there. So if somebody has any problem in the Zoom class, you are always okay in joining in YouTube live also. Fine. Lakshita, I think you are attending the second class if I am right. Unmute yourself.
Yes, sir.
Last class you were there if I am right.
Yes, sir.
Okay. After that you went to Tirupati.
Yes, sir. Yes, sir.
So you prayed and you came back, right?
Yes, sir.
Hopefully now things will be fine. Okay. Fine, coming back. So last class you are not there. Were you there?
No, sir. Physics class I was there.
Understood, yeah. Last physics class means when I taught work, energy and power, you were there if I am right.
Yes, sir. I was there.
Fine, thank you. Then it is fine. So before I start my today's class, let me give a quick recall to whatever I have taught in the previous class. So in previous class, we started learning about work, energy and power, where I told you what is the meaning of the word work. Technically, work is dot product of force and displacement. So when you take force vector, displacement vector, multiply them by using dot product, then you get a scalar result which is called as work. So work, it is dot product of force and displacement vectors. If I open the dot product and write, work done will become equal to Fs cos theta. This formula is valid only for constant forces. That is, the force does not change. At that time, this formula can be used only for constant forces. Work done is equal to Fs cos theta, where theta is the angle between force and displacement. I told you that day how work done can be positive, negative and 0. Totally depends upon theta. If theta is an acute angle, that is, its value is within 90 degree, less than 90 degree, then you are going to have a positive work done. That is, direction of force and displacement will be in the same direction. If theta is 90 degree, that is, force and displacement are perpendicular, then the work done will be 0 by that force. And then if the angle between the force and displacement is 180 degree, then the work done will be negative. 180 means from above 90, less than 180. I even told in that class the reason for all these things, why it is happening. And I gave you example also. That is, work done by the applied force being positive, work done by the gravitational force being 0, work done by the normal force being 0, and work done by the frictional force being negative. I could make you understand how it became positive, negative and 0. Then I taught to you about what is the work done by a variable force. In real life, we don't come across constant forces. Like I told you, if I ask you come and move this object with 10 Newton force, you cannot move. You will move with some force, but that force cannot be guaranteed to be only 10 newtons. It will be varying force. If the force is a variable force, then we find the work done by using integration, which is work done is equal to integral of f dot dx varying from x1 to x2. So, this kind of questions, whenever they give the force value to you, they will give in terms of x as a equation. Put in the equation, integrate it within the limits, you will get the work done. Third method of finding work done I taught to you, I said you work done can also be found by using graph. If it is force displacement graph on the displacement axis, if you find out the area, you get the work done. So, whenever a graph is drawn, remember these things, very important thing I am telling. Yes. Yeah, any example you can take. Man, draw a graph like this. A graph is drawn. This is force, this is displacement. If I ask you what is the work done, find this area. Rectangle area is there, no? This area will give the work done to you. So, whenever a force displacement graph is given, find the area under the graph, you will be getting what is the work done. What you have to be careful is the area should be found with respect to which axis? Displacement axis, not the x axis. Some of you may say, sir, both will give same area only, no? In this case, imagine, no, not in this case also, because if displacement is like this, force like this, now tell me whether the work done will be same area. No, area under this will be 0, work done is 0. Are you getting why work done is 0? Because no area can be found below this line. But if the graph would have been like this, and if I ask you what is the work done, yeah, this area will give the answer to you, isn't it? So, always remember the area has to be found on the x axis, not on the displacement axis. Some of you are thinking that I am finding the area on the x axis. No, not like that. We are finding the area on displacement axis. If displacement axis is y, we will find area on y. If displacement axis is x, we will find area on x. Be very clear about this. After that, in the previous class, I taught to you what is energy, capacity of doing work, has same units and same dimensions as work. I taught to you what is kinetic energy. Energy possessed by the body by the virtue of its motion is called as kinetic energy. How fast an object is going, that much energy it will have. I clarified in the previous class to you why the formula of kinetic energy is half mv square minus u square and not half mv square. Half mv square is just scenario when u is equal to 0. If object starts from rest, then work done is, or kinetic energy is half mv square. If object was already moving and its velocity increased or decreased, then the kinetic energy will be half mv square minus u square. We derived this expression by using normal constant force. We derived this equation by using calculus, integration. Both ways I derived and showed in the class to you. Also, while deriving, I could tell you what is the meaning of work energy theorem. Work energy theorem says that work done is always equal to change in kinetic energy. It will definitely come in the school examination. Define work energy theorem and prove it. So, definition I told you, prove I told you. If you just write those things, you will get the marks. Up to here we have seen in the previous class, if I am right. And then some numericals you solved, I think 2-3 numericals you solved on that day. And today we are going to proceed from there. Today's class is going to be very important. Because two important things I am going to teach you today. One is about potential energy. One is about law of conservation of energy, apart from teaching power. That is my plan today. Today I am going to teach you what is potential energy. Don't think it is only mgh like 9th standard, it is much more than that. So, what is potential energy? What is law of conservation of energy? And basics of power. This is my today's target. If you cooperate, we will be done with this topic today. Let us start today's class and give the heading as potential energy. Today's first topic is potential energy. When you learned about kinetic energy, I gave the definition of it. I said definition of kinetic energy was energy possessed by a body by the virtue of its motion. Energy possessed by a body by the virtue of its motion is called as kinetic energy. Same way, right? Energy possessed by a body, all of you please write. Energy possessed by a body, energy possessed by a body by the virtue of its position or configuration, by the virtue of its position or configuration, by the virtue of its position or configuration, is known as potential energy, is known as potential energy. Now let me make you understand this. Please pay attention. If I have water, 10,000 liters water I have flowing on the roads, but same 10,000 liter of water is there in the tank of the terrace. Do you think they both have same energy? Obviously not. Just because you changed the position of water from ground to top, its energy changed. I hope you are understanding this. Its energy increased or decreased? Its energy increased or decreased? Decreased. Increased obviously, and we learned how it increased. But remember that down 1000 liter water flowing is like waste water going. But same 1000 liter water going on the tank, you can use it in your tap. If it is 1 lakh liter of water, it can cause flooding in your area. Suddenly tank breaks. The water can cause flooding. The energy can cause a lot of destruction. Why? Because of the position of water. Like this also we can understand. I have some keyring in my hand. Okay? If this keyring is kept here and the same keyring is kept here, do you think they have same energy? Obviously not. Keep your hand below, you will understand if I leave it. If you keep your hand below and if I leave it, it will hurt. Why it is hurting? Obviously you will say velocity. But before velocity, because its position changed, it acquired an energy. That energy this keyring has acquired is called as potential energy. You have a bow and arrow. Bow and arrow you have seen, right? At least in TV, serial or childhood for playing. Bow and arrow will have a string. Bow will have a string. On that string, if I pull my arrow and leave, what will happen? What will happen? Potential force, new thing. I changed the configuration of my arrow, isn't it? Change in configuration also can create some energy, and that energy is called as potential energy. One more example I will give you, loudly. Configuration, now if you are sitting, this is your configuration. If you are doing like this, that is your configuration. Sorry, I am in live. So, configuration means how you are. If you change your configuration, like you stand, your configuration changed. If you go and sit on the AC, configuration is different. So, configuration is some kind of position only, you can say. Like when the wire is like this and the wire has been stretched, its configuration changed. Are you good? Are you getting my point? Suppose you have a spring and that spring is pressed, its configuration changed, it will store some energy. Remove your hand, it will come back. Why it came back? Because some energy got stored inside it. This is called as potential energy. I hope you understood this. So, potential energy is the energy stored inside an object because of the virtue of its position or configuration. Now, we have 3 kinds of potential energy, not like your 9th standard where you learned potential energy is mgh. You remember this? Kinetic energy half mv square, potential energy mgh. This was 9th standard. If you studied 9th standard, studied, no? No, I explained the same answer. Okay. So, potential energy, the 3 types are, the first one that you already know, it is called as gravitational potential energy. Gravitational potential energy. The second one, which you will learn in detail, which class? 12th class, that is called as electrostatic potential energy. About gravitational potential energy, you will learn in the upcoming chapter. That is, after work, energy and power, you have system of particles, then you have gravitation chapter. There you will study about this in detail. About this topic, you will study in 2nd chapter of 12th, volume 1. Chapter name itself is electrostatic potential and capacitance. You will study about that. And the third thing, which you are going to study today in detail, that is called as elastic potential energy. elastic potential energy. So, potential energy is of three types: gravitational, electrostatic, elastic. I will tell about all three a bit, but in detail you are going to learn in upcoming classes or upcoming year only. Okay. First, I will tell one by one. Guys, please don't write anything now. Listen, understand the concept. I will give time for writing. Don't waste your time in writing anything. When I am teaching, listen, understand. Okay. I will come back. So, gravitational potential energy. As the name is saying, potential energy by the configuration of two masses. That is, if I have mass m1, if I have mass m2, because of this configuration they will have some energy. If you find an energy, it will be taught to you in the upcoming chapter. The force, the gravitational potential energy is given by, again, U only. I am writing it as U. The formula is G m1 m2 by R. R is distance between their centers. If you are worrying how this formula came, will be taught to you when the chapter comes. But this is the energy possessed because of this configuration. You may ask, sir, what if there are three masses? Possibility is there, right? One mass here m1, another mass here m2, another mass here m3. Then what? Our distance is, suppose, r1, r2, r3. Then what is the energy of this configuration? You may ask. I will say energy of this configuration will be U is equal to G m1 m2 by r1 plus G m1 m3 by r3 plus G m2 m3 by r2. Ask me. R square is for force, right? What you are saying is F is equal to G m1 m2 by r square. That is the formula of force, man, not for energy. Energy formula is G m1 m2 by r. Again, I am saying, if don't worry how this formula came, it will be taught to you. If I start teaching that is different topic in the different chapter. But what is the meaning of gravitational potential energy? The energy possessed by two or more masses because of their configuration. So, energy, if there are two masses, three masses, four masses, is going to be separate based upon their separation. And how do you calculate that? By this formula. Same way, for electrostatic potential energy, it is the energy possessed by the charges. Suppose I am having charge, same like this I will write. I will have charge q1, another charge q2, distance between them is r. Then the potential energy is given by k q1 q2 by r. What was capital G, by the way? Capital G was universal gravitational constant. In 9th you studied again. Capital G is called as universal gravitational constant. What is its value? Its value is not 1.6 10 to the minus 19, man. 6.67 10 to the power minus 11. Very good. 6.67 10 to the power minus 11 Newton meter square per kg square. That is the unit of small capital G. Capital G is called as universal gravitational constant, and is K, its value is different. Its value is 9 into 10 to the power 9. Its capital G value was 6.67 and 10 to the power minus 11. So, this is the energy possessed by the configuration of charges. Once again I will tell you, if I have charges like this q1, q2, q3, then I will have the formula like this only. But here there is some difficulty. What difficulty is there, you know? Charges can be positive and negative also. Masses cannot be negative, m1, m2, m3. But here if you give you plus 2e, minus 2e, like that they will give you. Then we should write accordingly. Instead of writing plus, we will write minus here. Again, this will be taught in detail to you in 12th standard. But the formula, now I told you, formula is k q1 q2 by r. This is the formula of what energy? Electrostatic potential energy. So, gravitational potential energy is the energy possessed by the configuration of masses, and electrostatic potential energy is the energy possessed by the configuration of charges. Okay? You can write what you want to write. In detail, I will teach about elastic potential energy now. Next page. First, you can copy whatever you want to copy from the board. Whatever you want to copy, please copy from the board. I'll erase the board then. Paglavan, you please take the notes, man. Don't forget to take the notes. Shakti Varshini and Kirtana Rajashekar, why is your video off? Video should not go off.
Sir, I'm out of station, sir.
Okay.
Can I on the video after I reach my home?
Yes, 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 you can do that, no problem. Yes.
Energy possessed by a configuration of mass.
Energy possessed because of the configuration of masses is called as gravitational potential energy. Q represents charge. If you are wondering about then what is this formula of mgh, what is this mgh? Mgh is also gravitational potential energy only. It will come from this derivation only. You learned it. So mgh is a kind of gravitational potential energy only, which will be derived from this formula. K represents the constant, electrostatic constant. Its value is 9 into 10 to the power 9. Yeah. I am not erasing. Done. K is electrostatic constant. Electrostatic constant. Shall I go to the next page? Which is going to be an important lecture. Today's class starts from there only mainly. These things are just for making you understand what is the meaning of these two things. Exam point of view, what is going to come is very important. Shall I go to that? Shall I? Now you give the heading as elastic potential energy. Elastic potential energy. So as the name says, you may be understanding, it is the energy possessed by any material which is being elongated or compressed. For example, imagine, to make you understand this, see here, I am having a spring and I am connecting this spring with one mass. Everybody please pay attention. I will give time for copying. First you understand the concept. So what I am doing? I am taking a spring attached with a mass. Now what I do? I elongate this mass towards, or I pull this mass towards right. Okay. When I do so, spring gets stretched and the mass goes somewhere here. The moment I remove my applied force, that is, I took this object, pulled it like this, I am left leaving it. What will happen? It will go back. Do I need to push it? By itself it will go back. Why it is going back? Force that I have applied to move this object towards right, when I was moving it towards right, there was an energy getting stored inside the spring. And there was a restoring force developing in the opposite direction of my applied force. That's why the moment I left my hand, that restoring force helped the object to go back. Are you able to understand this? There is a spring, I pulled the object, based upon what force I applied, there is a restoring force developed inside the spring. Which direction? Opposite direction. That's why when I am removing my hand, with this restoring force, it comes back. Okay, my question to you is, one second, my question to you is, whether it will go and stop here in the original position? What it will do? It will overtake, overshoot, it will go towards left. Do you agree with me? Again, these things are common sense things. If I leave this, it will not come and stop here. Why is it not stopping there? Larger than applied force. No, not like that. Force applied? No. Gravity. Where is the gravity here, man? Tension. Huh? I'll tell you, there are two reasons for that. One reason, you know what is inertia? Inertia is the inability of the object to change its state of rest or motion. It came in motion, right? Inertia will not let it stop there. Inertia will not, suppose you're running and I say stop suddenly. You cannot stop suddenly. You need some 2 seconds to stop, isn't it? Car is going at very high speed. If driver applies brake, whether it will stop at the point of application of brake? Never. It goes some distance and then stops, isn't it? I hope you are getting what I am trying to say. Why? Because of inertia. Inability of an object to change the state of rest or motion. Okay. Second reason is, you will understand it today while I am deriving all these things, that at this point, the velocity of the object is maximum. If velocity is there, how can the object stop? So, one reason is inertia. Second reason is the velocity of the object, which will not make it to stop here. So, what it will do? It will overshoot and it will go where? It will go and compress the spring like this. Don't you agree? Once again, when it is compressing the spring, that time a restoring force will be developed in which direction? Opposite direction, which will make it to once again bounce back towards right. So, this object which was pulled towards the right and left will not stop there also. It will go, come, go, come, go, come, go, come. Am I right? You can feel that? It will start oscillating. It will start oscillating and it will stop. But because of friction, because of air resistance. Imagine if there is no friction, there is no air resistance. Imagine, theoretically. Then it will never stop. It's something like you would have seen, no? Pendulums, 6 pendulums together. One side you give, it will keep on moving. It also stops because of friction or because of loss of energy. If there is no loss of energy, that pendulum also should never stop. Same like this here also. Because we have friction on the floor, it will stop in some time. But how it will stop? Go to, fro, 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 stop. I hope you are able to feel what I am trying to tell you. Now, what is happening at every instant? When the force is acting towards right, restoring force acts towards left. When the force acts towards left, restoring force acts towards right, and restoring force is only making the object to go to, fro, to, fro, to, fro. If I take this displacement as x, what you are giving towards right or left, don't you think that this restoring force is proportional to x? Why I am saying, if you are pulling little less and pulling little bit more, pulling little bit more which case it will have more restoring force, the more you pull. So I am saying restoring force is proportional to x, or to be very precise, it should be proportional to minus x, isn't it? Why minus x? Opposite direction of displacement. If I am displacing towards right, restoring force is coming towards left. If it is getting displaced towards left, restoring force comes towards right. Are you understanding what I am trying to say? So I am writing restoring force is proportional to minus x. When you remove this proportionality sign and add a constant, that constant is called as spring constant, k. K is called as spring constant. And spring constant can be defined as force per unit displacement. Minus is there, but minus does not have to do anything with the magnitude. It just denotes that. I am writing here if you want. Negative sign indicates what? Indicates direction of force is opposite to displacement. Isn't it? This is the formula for spring constant. So what will be its unit? SI unit? Newton per meter, isn't it? It will be Newton per meter. Newton per meter. What will be its dimension? mLt power minus 2 by L. So it will become mt power minus 2, isn't it? Force is mLt power minus 2 and displacement is L. L gets cancelled, so mt power minus 2, isn't it? First you copy this. I have a lot to teach. First you copy this. Yeah. Come again.
The energy is conserved and the restoring force acts when we do both the actions, sir.
Yes.
When we compress also when we
Yeah, obviously. Anything you do, always restoring force will act in the opposite direction.
so like restoring force acts opposite displacement, sir.
Yes.
Then it's similar to frictional force.
It is, yes, it is similar to friction force. It is also having negative work done. Very similar to friction only. Yes. ஆமாம். நான் சப்போஸ் நம்ம இந்த பக்கம் கம்ப்ரெஸ் பண்ணுறோன்னா நம்ம கை ரிமூவ் பண்ணும்போது அந்த பக்கம் தானே வரும். ஆமாம், எல்லா elastic object applicable. If anything is elastic, if you try to pull this side, it will come back side. Any elastic, rubber is there, no, rubber band. Pull it like this, what will happen? Remove, it will come back. If rubber is there, press it, it will come back. புரியல. போகும். You properly check. If suppose from here you are starting and pulling, leave, it will not stop here, it will go little inside also. போகும், நமக்கு தெரியாது கண்ணில், because we are having a small rubber piece, but if you do an experimental setup, you can feel it is going inside. Okay. Make it fast. I will erase this part of the board because there are some more things I want to write. Shrish, something you are asking?
Sir, yes, sir. Sir, when there is no friction or air resistance, that restoring force will be equal fully, sir.
Yes, exactly. If there is no air friction or there is no friction by the surface, then whatever restoring force is coming, it will be equal to applied force and the object keeps on oscillating forever. Yeah. Which is not practical. Yeah. Friction is not, it will go in same force. It will go keep on going in same force always, because it will be not getting reduced because of any opposing force, no. Can I erase the board? Make it fast. I just want to erase this part. Just now started. Many things are still to be taught. Are you done? Fast, please. There you wrote already. I am erasing towards the right. Okay. Now please pay attention. I will give time to write once again. Please pay attention. My aim is to find the value of elastic potential energy. I have not got that till now. I just found what is spring constant value F by x. Minus indicates direction alone. So force per unit displacement gives me spring constant. But what is the value of energy? Like how we have a formula for gravitational potential energy G m1 m2 by r. We have a formula for electrostatic potential energy K q1 q2 by r. Like that, what is the formula of elastic potential energy? We have not yet derived it. Let us derive that now. How to derive it? Please pay attention. What we will do, first we will find small work done. Small work done, I am taking that as dW. If the object is displaced by small dx, it means I am finding if I displace the object a very small distance of dx, for doing that what is the work done? We have the formula f dx, fs cos theta. So can I write that the work done, small work done dw will become equal to f dot dx, or if I want to write open f dx cos theta. What is theta here? Theta is how much here? Force and displacement. If I am taking restoring force, what is the value? Cos how much degrees? 180 degrees, isn't it? I hope you are understanding what I am trying to say. What is cos 180, man? Minus 1, not 0. So the total work done I will integrate both sides. So dw integration will become w, and this will become f. What is the formula of f? Minus kx. This is how we learnt. Not ma here, restoring force. Minus kx we learned, no? So minus kx dx, cos 180 is minus 1, it will become plus. Are you getting how plus came? One minus came because of minus kx, and cos 180 also gave one minus 1. Minus minus became plus. I will do one more step for that. So I am writing integration. What is the formula of this thing? Minus kx dx, right? And cos 180 is how much? Minus 1. Limit I am taking from x1 to x2. This limit is 0 to w, and this limit is from x1 to x2 position. Okay. So now work done will become equal to, minus will come outside, and this minus will come outside, it will become plus, right? And then integration, k will come outside, integration of x dx. What is the integration of x dx? X square by 2. So my work done will become k into x square by 2, limit from where to where? X1 to, if I put the limits, this work energy, work is only stored as elastic energy U, which will become equal to 1 by 2 into k upper limit square minus lower limit square. So what formula I got? Careful. What formula I got? I got the formula as half k x2 square minus x1 square. Loudly. U always means potential energy. When I wrote gravitational also I wrote U only. When I wrote electrostatic also I wrote U only. And when I am writing elastic, that also I am writing U only. U means potential energy and K means kinetic energy. Okay. This derivation is clear to you? Check if any doubt is there, ask me or copy it. Yes, K is spring constant. Not this K I am saying, what we are learning last class, that is Ke I am writing, that is kinetic energy. This small k is spring constant only. Make it fast. Let me know if you are done. This derivation comes in the school examination very frequently. Can I proceed? Yeah. Raghav done? Chaitanya, what about you? Varshini, Sai Varshini, Shakti Varshini, whatever, Sai Varshini. Done? Yeah. Okay. So now please pay attention. We came to know that elastic energy stored inside the spring is given by half k x2 square minus x1 square, where what is x1, what is x2? x1 is the initial position, x2 is the final position. If I should have start from 0, x1 is equal to 0, and I should have taken the value of x2 as some x value, then what is the formula of u? U will become half k x square. Many books will write this formula only, because they will assume that we are starting from 0 and going to x. But I have taught you, even if they have given moving from some x1 position to some x2 position, you can find the energy now. But if you use this formula, it is only for the condition when x1 is 0, x2 is x. That is, spring starts from origin and goes some x distance away. So only then you can use this formula. But this formula can be used for any condition. Suppose they ask you, what is the elastic potential energy if a spring is displaced from x is equal to 2 meter to x is equal to 5 meter if it has a spring constant of 3. Then what you will do? You will use the formula half k 5 square minus 3 square. Am I right? But if you don't know this formula, then you will find u initial by putting half k 3 square, u final half k 5 square. You will subtract both. That is also correct way only, but lengthier way. Are you getting my point? If suppose I would have also derived this derivation by taking into my assumption that it starts from x is equal to 0 and it goes from up to x is equal to x, then what I will do? I will be getting the answer as half kx square only. But then if they have given the change from x is equal to some one point to some other point, then that formula could have not been used directly. Are you getting my point? If I would have given x1 is equal to 3 meter, x2 is equal to 10 meter, that is, the spring is moving from 2 meter to 10 meter. What is the energy stored in the spring now? Then how you would have solved? First you will find for 2, then you will find for 10, then you will subtract both. But now by this formula, directly you can put here 10 square minus 3 square, you will get the answer. I hope you get my point. So if you are seeing somewhere half kx square, they are also right. But this formula is only valid from x is equal to 0 to x is equal to x. But this formula is valid for any other scenario. You can write this also fast. Yes. Can I? Yeah. Copy it fast. You want, you can write. Yeah. This is correct only. Loudly. Obviously, they will specify. If they are asking to find spring is at rest, it is moved 3 meter away. What is the energy stored? Then half into k into 3 square. I hope you are getting. Have you copied that? Okay, now please pay attention. So this topic is very lengthy and every part of this topic is very important, and if you don't understand now, it will confuse you. So step by step I am teaching you, step by step you understand. At any point of time if you feel it is difficult, ask me there itself. So up to now we have understood that elastic potential energy is half k x2 square minus x1 square. If it is from 0 to x, then half k x square. Okay. Now let me go to the new page now, and let me once again draw all the scenarios. That is, my spring was initially at this position, then my spring was stretched to a different position, then if it is stretched, it will come back and it will go to a compressed state of this, and once again it will bounce back, it will keep on bouncing. So you can see very clearly that this is the kind of mean position, x is equal to 0, isn't it? X is equal to 0, this position. Now this position, let me draw a little bit left side. Is the maximum extreme towards the right. So I can write this position as from here to here is maximum extreme. I am writing x is equal to plus a, and this extreme can be done as x is equal to minus a. Do you agree with me? So from 0 it is going plus a, coming 0, going minus a, coming 0, going plus a, coming 0, going minus a. I hope you are understanding how it is oscillating. As per the friction and all these things, it will reduce, but I am not talking about that now. From 0 to plus x plus a, then 0 to minus a, to 0 to plus a, 0 to minus a. It oscillates like this. Okay. Now we are going to find, see, very important thing. Now we are going to find at each of these positions, that is at mean position or at the extreme positions, what is the value of potential energy, kinetic energy and total energy. Total energy means addition of kinetic and potential. Are you getting my point? Okay, now apply some common sense. When I am pulling it here and leaving it, don't you think that when the object is reaching its maximum position, its velocity becomes 0? Right? If its velocity becomes 0, then at extreme position, I can say that kinetic energy is 0. Do you agree with me? Why is kinetic energy 0 at extreme, you are understanding? Because at the extreme position, object comes like to rest. That's why it is changing its direction, no? See, it was going towards right, stops, goes towards left, goes towards left, stops, comes towards right. So object is oscillating between right and left, right, left, right, left, right, left. Why? Why? Because it is changing its direction at extremes. If it is changing its direction, it is only possible if its velocity becomes 0 in the extreme. Same way, what is the formula of potential energy, elastic potential energy? Half kx square. Since I am taking from 0 here, I am taking half kx square. At this position, x is equal to 0. So half into k into 0 square, it will become 0. So can I say that potential energy is 0 here? This is very important concept. Yeah, I'll speak, I'll say. The formula of elastic potential energy is half kx square, right, Lalit? At mean position, what is the value of x? Put here 0, what you will get? That's why I am writing u equal to 0. So at mean, u is 0. At extreme, kinetic energy is 0. You know what is happening? When I am changing the position from mean to extreme, the potential energy is getting converted into kinetic energy. At this position, all the kinetic energy is consumed and it has maximum potential energy. Leaving, its potential stops reducing, becomes 0. At the point where all its potential energy has become 0, it has converted into what? Kinetic energy. Once again, kinetic energy becomes maximum here, reduce, becomes 0 here. 0 means what? It has converted to which energy? Potential energy now. Once again, with that potential energy, it comes back. Are you getting what is happening here? When I am keeping at this position, kinetic energy is 0. Potential energy is what? Maximum. Releasing from there, potential energy slowly converts into what energy? Kinetic. So, suppose it has value of 10. 10 is becoming 9, becoming 8, becoming 7, becoming 6, becoming 5, 4, 3, 2, 1. But that 10 becoming 9, becoming 8, from 0 it becoming 1, becoming 2. So, your 10 of the potential becomes 10 of kinetic now. That's why the object not stopped here. Because at this point of time, all its potential became kinetic. Having kinetic energy, how it can stop? It will move only. Velocity is there. That's why it moved, went towards left. When it went towards left, its energy, which is kinetic energy, started to get reduced. Reducing means what? Getting converted into potential energy. At the extreme end, kinetic energy became once again 0 and potential energy became what? Can I write U maximum? And here what is maximum? Kinetic energy maximum. Understanding what is happening? So, extreme positions, kinetic energy 0, potential energy maximum. Mean position, kinetic energy maximum, potential energy 0. Third case only is extreme case, no? Once again, the kinetic energy became potential here. Body stopped here. All the kinetic energy became potential. Now, once again, it will start. So, potential will slowly become kinetic. At this point, potential energy will become 0. Kinetic energy will become maximum. It will go this side. Once again, kinetic will become potential, become potential 0. That is kinetic 0, potential maximum. It keeps on moving like that. So, when the object is traveling from mean towards extreme, kinetic is getting converted into potential. When the object is traveling from extreme towards mean, the potential is getting converted into kinetic. Is it clear to you? It means it is obeying law of conservation of energy. Kinetic becoming potential becoming kinetic. What remains constant, you know? Total energy. We'll prove that now. Any point, here, any point you take, random point, the kinetic energy, potential energy may be different, but total energy will be always same. Let us prove it now. Let us check it now. So, how to find that? Let us understand. Please pay attention. This derivation also is very important. So, at extreme, I will give time for writing. Please pay attention. At extreme, what is 0? Kinetic energy 0, potential energy maximum. What is the maximum value? Plus A. So, half into K into A square. Do you agree with me? What will be total energy? This plus this, how much that is? Half K A square. At mean position, potential energy is 0. Total energy is conserved. Total energy will be how much? Half K A square. So, what will be kinetic energy here? Total minus potential. Do you agree with me? See how I have done this. Why I have wrote this suddenly here? Because we know that total energy is conserved. Since total energy is conserved, whether you take this point or this point, it should be same. So, at this point we found total energy first. How much came? Half K square came. So, at this mean position also total energy would have been same only. Potential is 0. What is kinetic then? Half K square. So, I got the value of kinetic potential, total here. I got the value of kinetic, potential and total here. If you see kinetic energy, here and here different only, here it is 0, here it is half kx square. Potential energy here and here different only, here it is half ka square, here it is 0. But total energy here and here it is same. Okay, one more thing I will tell you. This is simple. What is complicated is, if they give you some random place, like suppose here, from mean I am going x distance away, and then they will ask you, at this point what is the value of kinetic energy and what is the value of potential energy. How will you find that? Final minus? What final minus what initial? By that you will find what? Potential energy, kinetic. Once again my total, what you are thinking is correct only. So at this position, if I want to find, let me assume this position is x. So what will be potential energy? Half k x square, isn't it? And what is total energy? Half k a square. So what is kinetic energy? Half k a square minus x square. We also came to know general formula of kinetic energy of spring. General formula of potential energy is half kx square for spring. General formula for kinetic energy of spring will be half k a square minus x square. At extreme you will put x is equal to plus or minus a, isn't it? Put here a square minus x square will become 0, so kinetic energy will become 0 here. At mean you will put x is equal to 0, put x is equal to 0 here, half k a square, same thing only came, no? I will repeat, listen carefully. At distance x, random distance x, I have tried to find what is the value of kinetic energy, potential energy and total energy. Total energy is known to us because of conservation of energy, it is going to be same half k square only. This total energy half k square only. Potential I know by the formula half kx square, I am writing half kx square. Total I know. What will be kinetic then? Total minus potential. This minus this will give me half k a square minus x square. This is what? General formula of what? Kinetic energy of spring. Kinetic energy of spring. So we got general formula of kinetic potential energy of spring, half kx square or half k x2 square minus x1 square. Same way general formula of the kinetic energy is half k a square minus x square. So extreme position minus the position that is given, you can find the value of kinetic energy. If you have understood this, copy it fast. Loudly. Yeah, if you put the value of minus x square, it will become a square only, no? Plus a square or minus a square, both are going to give the same result only, no? Got it? Make it fast, please. It won't come. Pagalavan, you are understanding what I am teaching?
Yes, sir.
Are you taking notes properly?
Yes, sir.
Okay. Are you done copying? Make it fast, please. Shall I proceed? Shall I proceed? Make it fast, please. Ayashini. Done at least now? Can I proceed further? Raghav, fast, fast, please. See, understand, I need not to say that, common sense. Extreme, what is maximum? Potential is maximum. Kinetic energy is? So when the object is moving from extreme towards mean, what became maximum? What became 0? What became 0? Potential energy. It means what would have happened? The potential energy here got converted into what energy? Kinetic energy. So when we are going from extreme towards mean, my potential energy is getting converted into kinetic energy. And at the mean position, kinetic energy became maximum, potential became 0. So all the potential became kinetic. Now, when we are going from mean to extreme, kinetic was maximum, kinetic became 0. But potential was 0, potential became maximum. It means all its kinetic was given to what? Potential. Are you getting my point? I can proceed now. So we have come to know that potential energy formula is half kx square and kinetic energy formula is half k a square minus x square. Do you agree with me? For a spring, potential energy is how much? Half kx square, where k is spring constant. This k is small k, which is spring constant. And kinetic energy is half k a square minus x square. So, if a question is asked, like, what is the velocity at a particular point? Like here, energy we know, but what is the velocity of the object? Then what will you say? If they ask velocity at the extreme, you will say 0. But velocity at some value, at some distance, we can find very easily. How you can find, See, kinetic energy formula is what? Kinetic energy is half mv square because starts from rest. So half mv square is equal to half k a square minus x square. Half gets cancelled. We get the value of v as k by m into a square minus x square root over. And at extreme, at mean we will find. At mean, what will be the value of x? 0. Do you agree? At mean, what is 0 here? X is 0, no? At mean position. So at mean x is 0, put x is equal to 0 here, you will get the maximum velocity formula. Maximum velocity will be root of k by m into a square. If a goes outside, I can write this value as V max is equal to a into root of k by m, that is spring constant by m. Clear to you? This is general velocity formula. If you want to find extreme, you can find it becomes 0 only. See, x becomes equal to plus or minus a. If it is plus or minus a square minus a square will be 0, and we know already it is 0 in the extreme. So velocity of the object at any point of time is found by the formula root of k by m into a square minus x square. From this part, questions come very frequently in competitive examination and sometimes in school exam also. In CBSE schools, they are asking questions from here, numericals, and obviously in competitive exam it comes. Yes, Lalit, loudly. I am making question for you. Huh? What will definitely come is this derivation of potential energy of spring. That will come definitely. But question will come or not, how I can say, man? If you permit me, I'll erase the board. X square only. Done? Copying?
Yes, sir.
Okay, now please pay attention. Please pay attention. One important thing. Again, it comes in the examination, Lalit. That is the graph of this kinetic energy and potential energy. It comes in the exam. So this central point is mean position. X is equal to 0. Let this be x is equal to plus a. Let this be x is equal to minus a. We know very well, at mean position, kinetic energy is maximum, potential energy is 0. So let me plot that. I am plotting the potential energy here. Potential energy is 0. I am putting it here. And kinetic energy is maximum. I am putting it here. What is the value of kinetic energy? Half k a square. You remember? Okay. At extreme position, what is kinetic energy? 0. What is potential energy? Maximum. What is the value of it? What is the value? Half k a square, and here also maximum. What is the value? Half k a square. If I connect the yellow dots, I am going to get the graph of which energy? Potential energy, isn't it? Here u is equal to 0, and here once again u is equal to half k square. If I am going to connect the white dots, then I am going to get what graph? Kinetic energy graph. And what is that? At this position, kinetic energy is 0. At this position, kinetic energy is 0. At this position, kinetic energy is half k square. If you see the graph carefully, then you will realize that at extreme, at this 0 plus half k square, how much you are going to get? Half k square. At mean 0 plus half k square, half k square. At extreme 0 plus half k square, half k square. It means from any point to any point during the journey of spring, its total energy remained constant. It never changed. How much it was? Half k square. Only the kinetic energy was changing and potential energy was changing. But total energy remained always constant. Is it clear to you? We also have found in this topic up to now that the formula of elastic potential energy stored in the spring is half kx square. The formula of kinetic energy when the spring is moving is half k a square minus x square. The value of velocity is how much? Root of k by m into a square minus x square, and the value of maximum velocity, which is where? At mean, is a into root of k by m. These things are important takeaways from this topic. U, k, and obviously total energy will be half k square. If you want to write that also you can write. U, k and total energy is how much? Half k a square. Is it clear to you? This topic is done. Copy. Now we will go to the next topic. Big topic it was. We have finished all the things. This derivation as well as the numericals from this topic are quite coming in the examination. Okay? Maybe in the practice class we will get some numericals from here. Don't forget, all these formula are important. Again I am repeating, this derivation is asked directly in the examination also. Shall I proceed further? Make it fast, Raghav. Soumya, you are understanding? What kinetic energy? Spring. Why it is not? Why it is not that? Because we derived and we got this value, man. We derived it, check. Total energy minus potential energy gives kinetic energy. There we derived, no? Total energy is half k square, potential energy is half kx square. Subtract both, you will get half k a square minus x square. Got it, Raghav? If you are done with this, see in this derivation, I directly took law of conservation of energy, right? Without even learning what is that. But before we go to that, you should write one more thing, which is the relation between, write that, relation between force and potential energy. relation between force and potential energy. Write it down first. Force is negative gradient of potential energy. Force is negative gradient of potential energy. Negative gradient of potential energy. It means F is equal to minus du by dx. When I say gradient, it means differential. If you differentiate the potential energy, then you will get the force. Remember this. Force is negative gradient minus du by dx. Sometimes they will give the equation of u in terms of x equation. Differentiate the function, you will get the force. And from here I can also write that du will become equal to minus f dx, and that is true only, no? Work done, force into displacement is work done only is energy. That way also you can understand. Either you understand like this or you understand like this. Okay. There is a topic called as equilibrium, which is not there in school syllabus. It is there only in Sunday's class. So I will teach there about that. Not required here. It's not there in your NCERT book about equilibrium. That is stable equilibrium, unstable equilibrium, neutral equilibrium. Those things I will come to that topic where I teach that in the competitive class. Not required here. Okay. Coming back. Now you give the heading as law of conservation of energy. Next topic is law of conservation of energy. Let us learn this topic. Again, this topic was taught to you in 9th standard also. It is a repetition topic. How much you remember 9th, I don't know, but let us learn it now. So first write the statement. Energy can neither be created, nor be destroyed. Energy can neither be created nor be destroyed. Energy can neither be created nor be destroyed. It can only be transformed from one form to another. It can only be transformed from one form to another. It can only be transformed from one form to another. Now to prove this, I will do an experiment. Please pay attention. Please pay attention. Very simple. This thing was there in 9th also. I am repeating it. But I am 100% sure you would have forgotten from 9th. I am repeating it. Please pay attention. What I am doing, I am having a mass at height h from the ground, and I am dropping this mass from here. What will happen? This mass will come towards the earth, it will come down. What I am interested in finding, I am interested in finding what is the value of energies at this point, that is starting point, somewhere random point, and third is at the end. Are you getting what I am going to do? I am going to find what is the value of potential energy here, what is the value of kinetic energy here, and what is the value of total energy here. Same way, the value of u, k and t for this point. Let me write as u1, k1, t1, u2, k2, t2, and last position, what is the value of u3, k3 and t3. What I am going to do, is it clear to you? My aim is to find what is the potential energy, kinetic energy and total energy at different positions. One is at the maximum position, second is some maybe x distance below the maximum position, and third is in the ground level, right? Okay. So when you drop the object from the top, what is its velocity? Initial velocity 0, dropping it. So, first I am taking the case 1. Case 1. I will give time for copying. Pay attention, understand the concept, then you can copy by your own. Very simple thing it is. So, case 1 I am writing, since u is equal to 0, can I write v square is equal to 2gh? Any problem in this? Since v square is equal to 2gh, can I write kinetic energy is equal to half mv square? Okay. So, it will become kinetic energy is half into m. Actually, I should not write v square, rather I should write starting velocity will be u, no? Half m u square it will become. Why u square it will become? Starting point I am taking. Starting point velocity is u. So, what is u? 0. What will be kinetic energy? What is potential energy? mgh. Height is h there, first point. What is the total energy? This plus this. 0 plus mgh is how much? Clear to you what I have done? So, I got the value of kinetic energy. How much is that? 0. I got the value of potential energy. How much is that? mgh. And what is the value of total energy? Same mgh. What you are asking? U how mgh came? That is a formula from our childhood, no? Potential energy is mgh. Potential energy is mgh. How it came, shall I tell you? I will tell you how it came. Potential energy, work done is equal to what? Work done is equal to force into displacement. If anything is going from displacement x or displacement h, then force acting is mg downwards, isn't it? So, force is mg, height is h, so mgh become the work done. That work done is stored as a potential energy. Okay. So, potential energy is mgh for the object at height h from the ground level. Okay. Coming back, case 2, please pay attention. Now, I am doing case 2. Case 2 is when the object is x distance away from the top. Okay. Now, what is the value of v square? This here we not used v square, it is like simply I wrote. Yes. So, now v square will become equal to u is 0, so 2gh, am I right? Initial velocity is 0, but velocity will have some value here, it is falling down. How much is that? 2gh. So, what will be kinetic energy? Half into m into v square. I should not write 2gh by the way, I should write 2gx, isn't it? I should write 2gx. Why I am saying x? Because how much it covered from top to here? The formula is v square is equal to u square plus 2as. U is 0 here, a is g here. Distance how much covered from here to here? X only, no? It should be half, that is 2gx and not 2gh. Okay. So, half mv square, so kinetic energy will become equal to how much? Half into m. What is v square? 2gx. 2 gets cancelled. What is the value of kinetic energy? mgx. Do you agree with me? What is the value of potential energy? From here to here, what is the height? It will be h minus x. Do you agree with me? Total is h, this is x, this will be h minus x. So, what is the value of potential energy? Very good, mgh minus x. Right? We got the value of k, we got the value of u. What is the value of time total energy? Add both. mgh plus mgh minus mgx gets cancelled. How much you got? Got it? Case 3. What is case 3?
Here's the plot synopsis for case 3.
Case 3 I told. Okay. Case 3. Case 3 is the value when the object is reaching the ground. If it is about to touch the ground, then what will be the value of V square? Now V square can be written as 2gh, right? Because now it has come from top to the bottom. Distance covered is h. Okay. What will be kinetic energy? Half mv square. So instead of writing V square, I can write kinetic energy as half into m into V, I can write 2gh. 2 gets cancelled. I got kinetic energy is how much? 2gh. Sorry, mgh. mgh. What is potential energy here? Why 0? No height in the ground. I have come to ground level. H became 0 from the bottom. Total energy how much? Don't you think it proves the law of conservation of energy? Total energy mgh. Total energy mgh. Total energy mgh. So wherever the object was, whether it is here, that is here, it is here, here, anywhere it may be, its kinetic energy may change, its potential energy may change, its total energy will never change. Same like the previous spring case, what is happening, you know, at the maximum height, potential energy is maximum, kinetic energy is 0. It's coming down, its potential energy is starting getting converted into kinetic energy. At the bottommost point, all its potential energy became kinetic, so potential became 0, kinetic became maximum. Is it clear to you? This proves the law of conservation of energy, which says that at any point, total energy remains same. If it is clear to you, copy it fast. We are going to finish the class. If it is clear to you, please copy this derivation. Law of conservation of energy. Let me know when you are done. Done? Make it fast, please. Copied? Done? Everybody? I'll close in 2 minutes. Last one, not concept, same concept. I am going to tell you how the questions are going to come from here. Now, from law of conservation of energy, very conceptual question will come. Again in the competitive class plus school class, whatever class it may be, the questions that are going to come is going to be very conceptual. I'll tell you how. Simple also, it is interesting also. They will say like, there is a boy who is sitting on a swing, girl, boy, whatever. Assume that the mass of the person is 50 kg and this person is sitting on a swing and in the extreme position, height is 5 meters above the ground, too much actually, assume. And if it comes down, then its height is around 2 meters above the ground, okay. It goes like this. Are you getting my point? So, they give the height at the mean position. How much is that? 2 meters above from the ground, and in the extreme position it is 5 meters above from the ground. Now, they ask you, what will be the velocity of the boy when he is at the mean position? So, they are asking you to find what is the velocity at mean position. How do you solve this question? Any idea? Solve it. This kind of questions will come in the exam. This simple question I am giving you. After this, level will increase. This is a very easy question, school level question this is. Give a try. You may be right or wrong, I will help you. We will do this question, then we will wind off the class. Yes, Karthikeyan.
It is 0, sir.
What, man?
Sir, at mean level it is 0, sir.
At mean level the velocity is 0. It means the boy will stop here. Imagine you are sitting on a swing, man. You will swing like this, no man? Then how will the object stop here? It will not be 0 for sure. Check your answer. Any answer? Anybody else? This kind of question can be solved by using the law of conservation of energy. How you know? I will find total energy here. What is that? mgh, which will be m into g into h is 5. Do you agree with me? M I am not going to put because it will cancel, I know. At this point, what is the total energy? Tell me how much here? mg2 plus half mv square. Do you agree or not? Some height is there, some energy will be there, and here there is no velocity, so I am taking only mgh. Now I told you energy is conserved, this both should be same. This value and this value should be equal because total energy will not change, right? So what I will do? By law of conservation of energy, I am writing mg5 is equal to mg2 plus half mv square.
Sir, is the velocity root 59?
I don't know, maybe. Gets cancelled, all three. And I can write v square by 2 is equal to 5g minus 2g is how much? 3g. So V will become equal to root of 6g. Root 60, yeah, as you told, Shri Krishna, good. Your answer is right. Root 60 will be somewhere around 7 point something meter, meter per second, obviously. What? How? See, at this position, kinetic energy how much? Loudly. At the extreme position, what is the kinetic energy, Raghav? 0. What is the potential energy? How much is that in this case? mgh. mgh is 5. So I wrote mgh plus 0. At this position, what is the value of potential energy? You should not say 0, you know why? Because here height is there, man. So mg into 2. And what is the kinetic energy? Half mv square. Same thing I wrote. Then I equated both. One more way of solving is there. Please pay attention. Once again. If you are over smart, one more method you can use. This is also correct only. What is that method? I will take a reference line here. Now, what is the height it became? 5 minus 2 is how much? 3 meter. What is the energy here? Potential energy is 0. Kinetic energy is half mv square. Here, what is the potential energy? mg3. So I will write 3 mg is equal to half mv square. Mm gets cancelled. Same answer came, no? What we do, we draw a reference line and we cancel this 2 here. If I take this as the baseline, then here the height is 0, so potential energy will be 0, kinetic energy will be maximum, half mv square. At this point, kinetic energy will be 0, potential energy will be half mg into 3. So mg into 3 is equal to half mv square, gets cancelled, v will become 60g only, that is 660 only, root 60. Don't confuse if you are not understanding. If you are not understanding, don't confuse. Use the old method itself. But this method also will be correct and it will save time for you. If you are in competitive class, I will say use that method only. Save your time. So whenever this kind of question comes, draw a reference line and reduce the number of unknowns. Okay, whatever, how much ever you understood. If something is there you want to ask me, please feel free to ask me. Pagalvan, you can wait for 1 minute. Others can move after you are done in this question. Okay? Yes, those who are done can start moving. Pagalvan, you can wait for 2 minutes.
Thanks, sir.
Yes.